Hi there students, this is question number 5 and it's also the last one that I'm going to make a screencast of. The remaining 2 questions I'm going to put on Blackboard as a test or an online homework for you guys to complete. This question tells us it's a directional test, and judging from the table that I've already partially constructed, you can already guess that this is going to be a T-paired test. But let's read the rest of the question and discuss why it's going to be a T-paired test. The question then reads, an online shopping company, Fast Books, advertises that they deliver books bought from them faster than any other online shopping service. A class of stats students decided to test this claim, and 12 of them ordered books. 6 ordered books from Fast Books, and 6 ordered from a different online shopping service. Each pair of students placed the call at the same time. So that is why one of the reasons why we realize that this is a pair test that we should be using. And what we also judge or gauge from the question is, even though the number 12 is given to us there, 6 of the students ordered from Fast Books, and a matching paired student for each of those 6 ordered from the other online service. So there are 6 pairs in this question, and that is why it's a paired T-test. The results in hours, so these students also place the call at the same time. The results in hours are recorded in the table below, and there we can see I've already calculated the difference in hours from using Fast Books and the other online service, and that was given to you in the question. So let's proceed. At 0.05 level of significance, test if the mean delivery time for Fast Books is less than the other online service. So because it's not asking you to try and establish is it the same or is it not the same as the other online service, it's specifically telling you want to test if Fast Books is less, which less in this case means it is the amount of time is smaller. There's less time involved when books are delivered from Fast Books. And so this is a directional test. Now, step number 1 is to calculate our null hypothesis. And a tip that I've actually prepared beforehand is it's good to remember that your alternate hypothesis is actually the hypothesis that sets out to prove your new belief about your population. So the null hypothesis tells you what you currently believe is happening in your population, or it states the status quo about the population. When it is not clear to me what the null or alternate hypothesis should be, truthfully, I've done this in class as well, I find it useful to write out the alternate hypothesis first, using what my question, what it states in my question. Using that information, I write the alternate hypothesis first, because that is what I want to prove, and then by implication use the opposite would be the null hypothesis. But also remember that the null hypothesis always has to include an equal to sign. If it's not a straightforward equal to sign, it is either more than an equal to or it is less than an equal to. And so, remembering that this is a T-paired test, we want to prove that these two are, we're setting out to prove that there's a difference. So, is the difference 0 or not 0? And so therefore, in the case of a one-directional test, what we are going to try and establish is, I'll start with the alternate hypothesis as I've explained, the mean difference between the two, because Fast Books states a new claim or wants to make a modification on the claim to say that their time is less than 0. the alternate hypothesis would say the mean difference is less than 0. The null hypothesis would therefore state that the mean difference is more than and equal to 0. I've just got to put a little d there to complete that hypothesis. Okay, so now what we do is we move back to our question and we need to complete this table. To complete this table, the first thing that we're going to do is we're going to calculate the mean difference. So I've taken the liberty of calculating it already by adding that all up and dividing it by 7, or just using your stats calculator to do that for you. Please remember, once again, it's very important that you take those signs into consideration. If you don't, you're going to get an incorrect answer. The mean difference is minus 2.5667. So the mean difference, I'm going to write here, mean difference is minus 2.5667. So when we go on and we do the standard deviation calculation, we take the difference between each of the pairs. So in the case of the first one, it would be minus 5.2, and we subtract. We remember that sign? We subtract minus 2.5667 for each of those. And we do that for each of the pairs. And I'm going to erase this because I'm explaining now that is how we do it, but I'm going to fill in the final answers there, the final answers that are pre-calculated for that. So for the first one, for the first pair, my answer that I got was minus 2.6333. For my second pair, the answer that I got was minus 0.9333. The third one, I got 0.5333. The fourth one, I got 3.6667. The fifth one, I got minus 0.733. And the final one, I got 1.1667. Right, this is used for calculation purposes to calculate the variance calculation. And the variance calculation, so all I do with these values that I got for each pair is I square them. And for the variance calculation, my answers that I got were 6.933343, 0.8710, 0.2844, 13.4447, is that correct? Yes. 0.5377, and finally 1.3612. Then what I need to do is I need to add these all up to have a final calculation that I'm going to use in my SD to calculate my SD. So the final answer that I have here by adding all of those values up is 23.4333. And this I'm going to use to calculate my SD. This I'm going to use to calculate my SD, and the mean difference, I'll remind you, I'll use in my test statistic. So let's move down again. Calculate my test statistic, and as I've mentioned, I need my SD to calculate my test statistic. So when I calculate my SD, I use the formula SD is equal to the square root of the sum of that variance. So the thing that I've just calculated in the table on the far right hand side, over n minus 1. So my n was 6, so that would be over 5. So this would be 23. I'm going to try and squeeze it in here. 4, 3, 3, 3 over 5. And that gave me an answer of 4.6867. And when I took the square root of that, according to my calculation, is 2.1649. I'm going to use this in my test statistic, and my test statistic would then be the mean difference. It is minus 0. The mean difference over that SD, which, actually let me write the formula down first. SD divided by the square root of n. And I'm just going to give myself some space here and make that line a little bit shorter so that I can fill in the values. The mean difference is minus 2 point, this is calculated on that table, 5, there we go, 5, 6, 6, 7, 5, 6, 6, 7 divided by 2.1649, but I first have to divide that by the square root of 5, the square root of 6, I beg your pardon, the square root of 6, so let me write that down, the square root of 6, and I'm going to just cordon this off. This is a separate calculation to what I'm doing now, so minus 2.5667 divided by the square root of, I'm going to say the square, where can I do this? The square root of 6 is equal to 2.4495. So that would be 2.1649 divided by 2.4495, and so it is minus 2.5667 divided by this calculation first calculate that, and the answer of that is 0.8838, and my test statistic in the corner here is minus 2.9042. I'm going to run out of time horribly, so I'm going to try and quickly, within less than a minute, explain about the critical value. Going back to our null hypothesis, the critical value will be on the left-hand side of the table, so it will be a negative value. To obtain the critical value, we're going to use the t-table at the relevant alpha, which is 0.05 as given to us in the question. At the degrees of freedom, n minus 1, it's 5 degrees of freedom, our critical value will therefore be minus, because of our null hypothesis, minus 2.0150. And then when we look at our test statistic and we compare it to our critical value, we see that our test statistic is beyond, I'll go to this, our test statistic is actually beyond the critical value. So if the critical value is minus 2.051 something, the test statistic is 0.9. it is rejected. It's in the rejection area. I'm sorry I'm not using 4 decimals. I just don't have time. 15 minutes is going to expire, and you therefore reject your null and accept your